Okay, a body starts from rest and they accelerate uniformly at 5 meter per second square until you attain a velocity of 25 meter per second. Calculate the time taken to attain this velocity. Remember I told you that if a body starts from rest, solution, if a body starts from rest, what is zero? Initial velocity is zero, u is zero. Then accelerate uniformly at what acceleration? 5 meter per second square is the acceleration. What is the final velocity? V equal to what? 25 meter per second. Calculate the time taken to attain this velocity. So what's the time taken? So which formula are you going to use that will work? V is equal to U plus AT. All the parameters are represented. What is V? 25 equal to 0 plus A. 5 times T. 25 equal to 5T, is it not? Divide by 5, divide by 5. What's the time? Time is 5 seconds. Okay, look at this one. A train has initial velocity. What is the initial velocity? U. And is what? 44 meter per seconds. And an acceleration of minus 4 meter per second square. Whenever you have minus in acceleration, it means that the acceleration is coming to rest, is decelerating. It's called retardation. So if it's in a slope, retardation slope is like this. Here is velocity, here is time, it's coming to rest. So it's minus 4 meter per second square. Its velocity is what we are asked. After what time? After 10 seconds. We still use the same formula. We have V, U, A, and T. So we use V equal to U plus AT. This formula will work because all the parameters are represented in the formula. All the given parameters are in the formula. So we are looking for V. What is the initial velocity? 44 plus what is the acceleration? Minus 4 times what is the time? 10. So velocity is 44 plus times minus is minus 40 equal to 4 meter per seconds. So the answer is 4 meter per seconds. Okay. If a car moves from rest with a uniform acceleration of 10 meter per second square for 10 seconds, the distance covered in the last 1 second of the motion is what? This question is a different question that you have to pay attention to. The last 1 second of the motion, what is the distance covered at the last 1 second of the motion? The total time is spent is 10 seconds. So the last 1 second of the motion is from the 9th seconds to the 10th seconds is the last 1 second of the motion. If they say the distance covered in the last 2 seconds of the motion, it's going to be from the 8 seconds to 10 seconds. That is from 8 to 10 is the last 2 seconds of the motion. But in this case, it's last 1 second of the motion. That is from the 9th seconds to the 10th seconds. That is distance of the 10 seconds minus distance of the 9th seconds. At 10 seconds, when the time is 10 seconds, what is the distance? If you start from rest, u is 0 and the acceleration is what? 10 meter per second square. Which formula will go that have s? The formula have s is s equal to ut plus at square over 2, is it not? So what is the distance at 10 seconds? What is the initial velocity? 0 times 10 plus what is the acceleration? 10 times what is the time? For the 10th seconds is 10 square over 2, right? So the distance is going to be 0.0 times 10 is 0. 10 times 100. 10 square is 100 all over 2, which is 1000 over 2. 1000 divided by 2 is 500. So at 10 seconds of the motion, the distance is 500. At 9 seconds, what's the distance it covered? At 9 seconds of the motion, it is going to be time, if it's 9, is going to be s equal to, if time is 9 now, time is 9. is going to be u. What is u again? U is still 0 times time is now 9 plus a 10, acceleration is still 10 times 9 square over 2. So what are you going to have? S is equal to 0 times 9 is 0 plus 9 square is 81. 9 times 9 is 81. 81 times 10 is 810 divided by 2. So 810 divided by 2 is 4 what? 405. Is it not? So the distance is 405. So the distance of the last 1 second of the motion will be the 10 seconds. Distance of the 10 seconds minus distance at 9 seconds is going to be the distance at the last 1 second of the motion. That is 500. Distance of at 10 seconds is 500 minus distance at 9 seconds, which is 405. So 500 minus 405 is 95 meter. So the answer is A, 95 meter. Okay, the next question, a body accelerates uniformly from rest. Anytime you hear that a body starts from rest, U is, if a body comes to rest, V is 0, final velocity. So the initial velocity is 0 at what acceleration? Remember that acceleration is meter per second square. So 3 meter per second square is the acceleration. And what is the time? Time is 8 seconds. What they're asking us to calculate the distance, S. Which formula have S and U? The formula is S equal to UT plus AT square over 2. You understand? We cannot use V is equal to U plus AT. S is not given. We are looking for S. V square is equal to U square plus 2AS. We cannot use it. Why? Because time is given. There is no time in this equation. So this is the best formula that will solve it. So S is equal to U is 0 times, what is the time? Time is 8 seconds plus A 3 times time is 8 square all over 2. So S is equal to 0 times 8 is 0. 3 times 8 square, 8 times 8 is 64 divided by 2. So 3 times 64 is 192 divided by 2, which is 96 meter. So that is the answer. Okay, let's solve this one. A particle starts from rest. The first one, a particle starts from rest. That is U is 0, right? And it covers a distance. S is what? 80 meters. Is it not? I believe you can solve the questions now. And what is the time? 10 seconds. Calculate his acceleration. Which formula will go? Which formula is going to go here? S equal to UT plus AT square over 2. Thank you. So S is equal to, what is U? U is 0 times time. Time is 10 seconds. Plus A is what we are looking for times time again. 10 square all over 2. Is it not? So S is equal to 0 times 10 is 0. 8 times 10 square is 100A over 2. So what are we looking for? We are looking for A. So what is S? X is what? X is 80, is it not? So I have to put the 80 here. Sorry, X is 80. So I have to do cross multiply. What do you have? 2 times 80 is what? 100A is equal to 2 times 80 is 160. So divide by 100. Divide by 100. So what is A now? 1.6 meter per second square. So that becomes our acceleration. The second one, a body starts from rest. Still a body is starting from rest. U is still 0 if it starts from rest. Accelerate uniformly at 5 meter per second square. Acceleration is 5 meter per second square, is it not? Calculate the time taken. Time we do not know by the body to cover a distance. Distance is 1 kilometer. We are working with meter per second, so we should work with meter, which is the SI unit of distance, because acceleration is also in meter per second. Acceleration is not in kilometer per hour. If the acceleration is in kilometer per hour square, we can work with the kilometer. So but the acceleration is in meter per second square. So we have to convert the 1 kilometer to meter, which is the SI unit of meter. 1 kilometer is equal to how many meter? 1000 meter. I believe you know that. So that is the distance. Distance is s. Let me use the symbol s so that you remember that s is equal to ut plus at square over 2. This will still work. What is s? S is 1000. What is u? 0. What is the time? What we are looking for? Plus, what is the acceleration? 5. What is the time? What we are looking for? T square over 2. So we have 1000 equals 0 times t is gone. So we have 5t square over 2. Cross multiply. What do you have now? 5t square equal to 2 times 1000 is 2000. Divide by 5. Divide by 5. So what is t square now? T square is equal to 2000 divided by 5 is 400. Is 400. So that becomes t becomes square root of 400. So t is equal to 20 seconds. A boy moving with a velocity of 3 meters per second is brought to rest. Let's solve the first one. Final velocity is 0 by a constant force after traveling a distance. So a body moving with a velocity of this, initial velocity is going to be 3 meters per second, while the final velocity is 0 because it's brought to rest. So by a constant force after traveling a distance s 15 meters, calculate the retardation. Retardation is the same as acceleration. Acceleration that is coming to rest, that is decelerating, that is decreasing with time. So what we have is, from this, we are going to have that v square is equal to u square plus 2as. So this formula is going to go because there is no time here. So we are using this to solve. V square is 0 square equal to, what is u square? U square is 3 square plus 2 times a. What is the a? That's what we are looking for, acceleration. And what is the distance? The distance is 15. So 0 square is equal to 3 square is 9 plus 2 times 15, which is 30a. Is it not? So this 30 come over here, you're going to be minus 30a equal to 9. Divide by minus 30, divide by minus 30. So what is the a? A is equal to what? A is 9 divided by minus 30, which is minus 0.3 meter per second square. The minus is an indication that the acceleration is decreasing, is coming to rest. That's why it is called retardation. So that is the answer. Then the next one is, I hope you get that. So the next one is a car moving with a speed of 90 km per hour, moving with a speed of 90 km per hour was brought to rest by the application of brake. The velocity is moving with is what? The speed is moving with, initial speed is 90 km per hour before it's being brought to rest. When it's brought to rest, final velocity becomes 0. Then, by the application of brake, in what time? 10 seconds. How far did the car travel? How far means distance, s. If they ask you how long did the car travel, how long means time. They ask you how far did the car travel, how far means distance. So we have to convert this to meter per second. So 90 km per hour should be converted to meter per second, which is 90 times kilometer to meter is times 1000. Per means division, hour is 60 times 60, right? So we're going to have 90 times 1000 is 90,000 over 60 times 60 is 3600. So this divide, this divide, this divide, this divide. 900 divided by 30. This velocity becomes the final velocity before it comes to rest. So having known this now, 25 meters per second square, we now say that we are looking for s. S is equal to ut plus at square over 2. So this formula goes. Do you know the s we are looking for? Do you know u now? Now, very important to take note that since we do not know a, A becomes this velocity over t. So A is equal to 25 over time is 10, which is 2.5 meter per second square. So S, therefore initial velocity now, if it's coming to rest, if it moves before coming to rest, that means the initial velocity here becomes 0 times time 10 plus A is 2.5 times time, which is 10 over 2. So S is 2.5 times 10 is 250 over 2. 250 divided by 2 is 125 meter. So the answer is 125 meter.